This is the chapter 1 review. If f of x equals x to the x squared plus 3, find f of x plus 2. So when we find f of x plus 2, we're going to plug x plus 2 in for x. And then we just need to do some algebra. Let's FOIL x plus 2. And we'll add 3, and that's equal to x squared plus 4. That should be an x there. Plus 4x plus 7. Find the domain. Well, you can't take the square root of negative values, and you can't allow the denominator of fractions to be 0. So 2x minus 1 has to be greater than 0. So 2x greater than 1, x has to be greater than 1/2. Use the continuity test to determine if the function is continuous at x equals 2. So if we plug 2 into here, we get the point 2, and then 4 minus 1 is 3. Well, then if we plug 2 into here, we get 2, 6. Now, these 2 points are not meeting at the same point. So if we have the limit as x approaches 2 of f of x or y, that does not exist because this side is approaching 3 and the other side is approaching 6. We also have f of 2 is equal to 6. Now, these two things don't equal each other, so we have a jump discontinuity for this one. Use the continuity test. We could say that f of 2 is equal to 6 minus 4 over, let's see, 4 plus 6 is 10. 4 plus, 4 plus, does this factor x, x plus 5 and x minus 2? I'll be darned, that does factor. So 2 is making the denominator 0. So the function value does not exist. Now, because x minus 2 doesn't cancel with something on the top, we can say that the limit as x approaches 2, that does not exist either because we have a vertical asymptote over here at 2, vertical asymptote. So it's either it could be doing this action or this action, and the limit as the function approaches that asymptote just doesn't exist. Well, even though those both don't exist, it doesn't mean they're equal. So we have an infinite discontinuity at x equals 2. Find the average rate of change for f of x from negative 2 to 3 if f of x is x squared minus 3. Well, average rate of change is going to be f of 3 minus f of negative 2 over 3 minus negative 2. Let's plug 3 in. 9 minus 2 is 7. Let's plug in negative 2. That's going to be 4 minus 2 is 2, so minus 2 over 5. So 5 over 5. And that's equal to 1. Now, this has to do with transformations. When you have a negative on the outside, that reflects over the x-axis. This a right here, that's going to be a stretch or shrink vertically by a factor of a. A negative on the inside, that's going to reflect over the y-axis. And then we have plus or minus c. That would actually be left or right. So left being the plus, right being the minus. And then plus or minus d is either up or down. Looks like I skipped one. This b right there, that is a stretch or a shrink horizontally by 1 over b. So you got to do the reciprocal for that one. Find f of g of x if f of x equals 3x minus 2 and g of x equals x squared minus 1. So f of g into f right there. So f of g of x, we're going to throw g in for that x. So 3 times x squared minus 1 and then minus 2, which is 3x squared minus 3 minus 2. So 3x squared minus 5. Determine whether f has an inverse function. If it does, find the inverse function and state any restrictions on its domain. So if we made a very quick graph of this, we have a vertical asymptote at 1. And then we also have a horizontal asymptote up here at 3. This is up here at 3. 3. And then, well, let's plug in 0. If we plug 0 and we get -2, so we're down here at -2. So on this side, it probably does something like this. And then if we plug in, let's say 2, that's 6 plus 2 is 8 over 2 minus 1, so 8. So way up here at 8. So this passes the horizontal line test. So no matter where you would draw a horizontal line, it would only cross one point. That means this function is 1 to 1. So 1 to 1, which means it has an inverse. So to find the inverse, let's put x in for y, and the y's in for the x. So y minus 1. Let's multiply by y minus 1 equals 3y plus 2. We're trying to get this to say y equals. So xy minus x is equal to 3y plus 2. Let's get the y's together. xy minus 3y is equal to x plus 2. So we added that x over. Now I can factor out a y and write x minus 3. All right, let's divide by x minus 3. And so instead of writing y equals, which is actually not true, y is equal to this right there. F inverse of x is equal to x plus 2 over x minus 3. And we got it. I think that's it. Yep, that's it.